Okay, I started the recording for YouTube, so we're gonna start solving the advent of code for 2022. A few ground rules, or I don't know, warnings, you decide. I solved partially the advent of code for last year, 2021. It's on YouTube, you can find it there. I didn't get to the end because at some point it got somewhat intensive and I messed up an exercise and kind of lost interest. So here's my personal perspective on this. Not everybody agrees with my take, but here's how I see this. I don't think that the advent of code is the best way of enjoying Zig. It's a reasonable, it's like the advent of code is intrinsically entertaining. It's entertaining on its own, so I can see people using the advent of code as an excuse to drive a Zig, so that's fine. But in my opinion, you will not see the full shine of Zig when doing the advent of code. And here's my reasoning. When you do the advent of code, you are writing one-off, throwaway programs that need to only get you to a solution. Once you have the solution, which is going to be like a string or something like this, your number, you copy paste it into the solution page, and you move to the next exercise, and your script, sure, you can put some care into it, it could be nice, but from the core goal that you're chasing with advent of code, you only need an answer. After that, your software doesn't matter anymore. Zig really shines instead when you're not doing this kind of like data science-y exploratory stuff. It shines the most when you're doing software engineering. As one example, Zig complains about unused variables. You don't care about unused variables when you are trying to solve a one-off advent of code problem. When you're doing like a big software development with a lot of people, there's a huge code base, then not having unused variables in there could be nicer. There's a flag, which is a work in progress, that should disable this error from the compiler, but it's not ready yet. But regardless, my point is, just so you know, but my point is, if you want to see the real power of Zig, you need to be doing proper software engineering. And advent of code, it's more data science-y than it is software engineering, in my opinion. That said, I'm gonna do it anyway this year, like last year, because at the very least, there's gonna be recordings out there that you can use and take a look at where is stuff in the standard library. Zig still is not gonna be bad to solve the problems, and you will find that despite the language being new, small, the standard library being relatively small and everything else, there's a lot of pretty good stuff in there that you can use to solve your problems. So that's what we're gonna do. I'm not going to try to find the best solution for everything all the time. Sometimes I'll brute force a solution that maybe could be solved in a better way. Maybe if there's going to be an opportunity, we'll try to solve a problem entirely at comp time. We're going to cheat. And by cheat, I mean we're going to cut corners to get to the solution in the laziest possible way, or close to, which means it's not always going to be the best possible solution. But this is mostly an excuse to show people what you can do with Zig today, what's in the standard library, so that they, if they are trying to solve advent of code on their own in Zig, they know what they can have access to. And on the other hand, maybe we're gonna use that as an excuse to show off some features that happen to solve a problem particularly well. And if I remember correctly, last year there were a few situations where that was 100% true. So with that, I think we can start. Let's go. Also, say hi to the chat, tweet chat. By the way, if anybody in chat has questions about anything related to Zig, please feel free to ask. I'm happy to answer. Even if it's not something strictly related to the problem that we're trying to solve, like the advent of code problem at hand. So, let's get started. I just built a new version of Zig. So right now I'm using 0.11 dev plus 525. So this means that I have an unstable build of Zig on my computer. I just compile it from source, but you can download it from the official Zig website, by the way. I'm not gonna go through the full process this year, but no, that's not where I wanted to go. Okay, we're getting there. Okay, I pressed down and then went back up. What? Safari. Okay. Okay, so you go to the website, you can go to the download section and you can download Zig. I think that if you download the latest stable, I'm not going to use any new syntax. There's almost no new syntax from what I'm using to 0.10, but you know, it's an unstable language, so the newer the better, generally speaking. I am pretty confident though that even if you go to here and download at some point a newer version than me, so one that is not just 500 something commits. This number counts the number of commits since the last stable release. So if you're using something that is going to be, I don't know, 600 commits or whatever, you're still going to be good. No real syntax changes this year. Is there a set data structure in the standard library? Yes, you can use a hash map and you just give it void keys. So let me show you. I'll show you in a moment. So let me get into my AoC folder. I'm gonna make a day one folder. Oh, I went into AoC21. Oops. So you want a set data structure. That's how you do it. Const, I don't know, int set is std dot hash map. Actually, you want probably auto hash map. And then usually you have to specify the key type and the value type. For the key type, let's say that you want to make a set of integers. So I don't know, usize. And then for the values, since it's a set, you don't have values, so you do void. And that's how you create your set data structure. So what you get from this is a set data structure backed by a hash map. Obviously, this could be good enough. It's not the only way that you can have a set. A set is I don't know, let's say like a more of an abstract interface. Like the concrete implementation could be a hash map, like auto hash map. There are also other implementations based on other data structures. I don't think we have any other way of getting like trivial way of getting a set from the standard library, but yeah, that's what you get from the studio lib. Anyway, you know what? I'll do this also. Touch main.zig, I guess. Yeah, now we have syntax highlighting and stuff. Hello, hey two-step. Hello. Okay, let's see. Also, wait, maybe other resources. Language reference, standard library documentation. If you don't have those, you should open those. Did you already mention dynamic bit set? I did not. I think that's very specific though. It's not a generic set data structure, right? Or maybe you know what the use case would be, maybe in the advent of code, and if so, I don't know, maybe that applies. But like, I don't think this is a good generic set data structure. That's why I didn't mention it. Also, I think I forgot about it. Let's see, dynamic bit set. This is the automatically generated documentation for the standard library. This is also something nice that you might want to use. It's not perfect yet, so always remember to refer to the source code. The source code is the ultimate truth. Also here, this link here in the yellow banner explains to you how the standard library is structured so that you can move around the source code on your own independently without needing any HTML crutch. So let's see. Dynamic bit set. A bit set with runtime known size backed by an allocated slice of usize, theme wrapper around dynamic bit set and manage, which keeps track of the allocator instance. Yeah. Find first set. Yeah, this is a nice data structure if you're doing, I guess, a certain kind of bit fiddling. Who knows? Maybe this will be, you know, a useful tool that will come in handy later on. Okay, let's get started. Calorie counting. Oh god. Santa's reindeer typically eat regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. What's magical energy? Oh, that's the 2018 exercise. Okay. For that, their favorite snack is a special type of star fruit that only grows deep in the jungle. The elves have brought you on their annual expedition to the grove where the fruit grows. You know that, I guess, when it comes to the Advent of God lore, these are supposed to be like the tiny elves that help out Santa, but I cannot, right now, for some reason, I cannot take my mind off the idea that, no, these are not those elves. These are like the elves. It's like, these are like the, I don't know, pointy, eared, Legolas style, very long, living, annoying guys from like Lord of the Rings and stuff. So the elves are doing this. Okay, so to supply magical energy, the expedition needs to retrieve a minimum of 50 stars. So okay, this is the usual starting prompt. Although the elves assure you that the grove has plenty of fruit, you decide to grab any fruit you see along the way, just in case. Collect stars by solving puzzles. 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star, good luck. The jungle must be too overgrown and difficult to navigate in vehicles for access from the air. The elves expedition traditionally goes on foot, of course. As your boats approach land, the elves begin taking inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying, your puzzle input. Okay. Are we eating elf? It's like how much calories they're carrying in their bodies or in their backpacks? Are we... Anyway. The elves take turns writing down the number of calories contained by the various meals, snacks, rations, what they brought with them, blah blah blah, line by line. Each elf separates their own inventory from the previous elf's inventory, if any, by a blank line. For example, suppose the elves finish writing their items' calories and end up with the following list. So it's 1, 2, 3, 4, 5 elves. This represents calories. First elf is carrying food with 1,000, 2,000, 3,000 calories, total of 6,000. Second elf, only 4,000. Third elf, blah blah blah. Okay. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000 carried by the 4th elf. This guy. Okay. Find the elf carrying the most calories. How many calories is that elf carrying? Okay, and that's my puzzle input. Okay. So select all, copy. I guess we want to make also a new file. How do we do this? New? Here's a new scratch buffer. No, open. Yes, open data.txt, I guess. Okay. We paste. Was there an empty line in the beginning? No, there was not. So we remove that empty line. Okay, how many lines do we have? Go to the end. 2,000 lines. Okay. So that's our data.txt. Perfect. Go back to main. Let's get started. Const. So we import the standard library. We need a main function, I guess. Do void okay. Use of unaccurate identifier. Oh, why is this freaking out on me? Okay, let me. I think the ZLS freaked out because of what happened. Oh, you know what? I have a new Zig. I should update my ZLS. That probably it's not a bad idea. So let's go do that. Surely nothing can go wrong doing that last minute. Yeah, so you kind of want the language server to be updated if you're updating the language. That's reasonable, I guess. Okay, so we're good. Now we need to get the data in here. I don't know how you do this in other languages. I don't know how you did this on your own. If you're being a good boy, you would open a file, maybe accept the file name as a command line argument, read the file, do the proper buffering, blah, blah, blah. We're not doing this. Here's what we're doing. That's how it works. We are embedding the data, the puzzle input, in the executable at compile time. So why am I doing this? Is it a good idea? No, it's just that it's the shortest path. It's like, it's one line, it works, you don't have to worry about stuff. Sure, if data.txt was, I don't know, 50 megabytes, maybe you don't want to do this. But since that's not part of our constraints, I'm not gonna worry past. I'm not gonna try to do the, the software engineering correct thing, because we're not doing really software engineering in that amount of code. So there's no point in trying to pretend. This works, so let's do it. Next, we need to read this thing line by line. So it's time to introduce the star of all advent of codes, which is tokenize. std mem tokenize, this guy. Tokenize takes a type, takes a buffer, and takes some delimiters. So returns an iterator that iterates over the slices of buffer that are not any of the bytes in the limiter bytes. So, well, there's an example, blah, blah, blah. Okay, let's use it. So we could tokenize bytes. Our buffer is data. Our delimiter bytes are going to be, I think we want just new line, right? And then that gives us an iterator. Next, we need to keep using the iterator. So what we want to do is find which elf has the highest amount of calories. So I guess we want a counter. That's gonna be easy. I'm gonna put it up here. So var actually, you know what? Max calories. So we keep track of what is the maximum that we saw in the past. Then we have the running counter. Hello, CryptoCode. 0. Next to 0 in here. So we have a counter, and then while we have new lines, we do it.next. It.next gives us a new line. Now, now this line is going to be a string. Now we need to make a number out of it. We need to parse an integer out of it. Parse int. Parse int. Another library, fmt parse int. Parse int. We need to provide the output. So previously we had to provide the type that we want to tokenize. It seems silly because most of the time you want to tokenize bytes, except when you don't want to tokenize bytes. Sometimes you want to tokenize something that is not just a U8, but I don't know, like you're tokenizing 32-bit Unicode, the UTF-32, then you want to pass to U32 in here. Maybe, depends on what you're doing. But in this case, this argument is different. This one is the type of int that we want to get out of parsing. Parses the string buff, so we expect so this one works on byte arrays, doesn't expect a weird encoding, just expects normal, like, UTF-8 with numbers, which means ASCII pretty much. And also it understands if you're trying to do signed or unsigned based on the comp time type. So for example, if you're trying to get a I64 out of the string, then it will accept the minus, otherwise it won't, I guess. And yeah, when you specify T is what you're getting back. And then you also have to specify the radix, which in our case is going to be base 10. So when radix is 0, the string prefix is examined to detect the true radix. Interesting. That's a relatively new feature. It wasn't there in the past. That's pretty cool, but we don't care. We know what the base is. So const number is try std fmt parse int. Type is gonna be usize, good enough. Buffer is gonna be our line, and the radix is gonna be 10, base 10. This produces a potential parse error, but we're gonna try. So we're gonna basically panic. So the error bubbles up from the main function. When you bubble up an error from the main function, normally that produces a panic in Zig. So because there's nothing that can, or rather, panicking is how Zig handles an error return from the main function. Anyway, yeah, but in any case, this is not really gonna fail, is it? Or is it? Let me think about it for a moment. It should fail when the line is empty. Well, I don't know how this behaves. I don't remember if it... I don't think it will return 0 on an empty string. I think it will fail. So we need to handle a case. So we need to ask ourselves, okay, when is a line empty, we need to do something. So because it's a new alv starting. So I guess if line.len equals 0 or 1. 0 or 1. Do we have the delimiter when we tokenize? Do we bring it with us? I don't think we do we? Does it say? Yeah, so this is trying to tokenize a string with some spaces. And this has the return slices without the space. So we do not get the delimiter. So that means that we expect the line to have length 0. So when the line is length 0, what do we do? When the line is length 0, we basically want to... We know that the count, we accumulated everything that we needed to accumulate. I guess we check it with the previous max that we saw. Write it down if it's bigger. And start again. So, empty line. Now, if counter is greater than max calories, then max calories equals counter. Write it down, and then regardless, we want to reset the counter because we are starting with a new alv. And once we are done with this, we continue. We start a new loop with the iterator. Then every other time, we grab the number and then we add it to counter. And then at the end, we print max calories. But does this end with a new line? Does the data end with a new line? If the data, so go to add, yeah, the data doesn't end with a new line. That's annoying because if there's no new line, then our algorithm is wrong. We could fix the algorithm or we could fix the data, which is what we do. I'm adding a new line so that we know that the do the comparison thing happens also for the last one. Not something that you can usually do with software engineering, right? You don't have that. Sometimes you don't have that control over the data, but it doesn't matter. Doesn't matter. Just like we are not really handling syntax errors. We don't expect syntax errors in the data format. I think this is it. Time to see if it works. Ooh, expected type. Pointer to mem to error font const. Oh yeah, terrible mistake. So the iterator, I tried to stuff the iterator struct into a constant variable. The problem is that next wants to modify the state of the iterator. That's why we're using an iterator, so that it can hold a little bit of state about our iteration stuff. So const doesn't cut it. So what happens? Here's what's happening. We stuff this into a const variable, which by itself is not, like, it's wrong based on the upcoming use, but in on itself is not directly wrong, so this is allowed. The problem is that when we try to call next, and next, can we go to definition? Yeah, I did go to definition. Next tries to grab a pointer, a mutable pointer to self, because understandably wants to modify index. Oops. So yeah, that's not good. So go back to main. The problem is that from a const variable, you can only derive a const pointer. So we need to make this a normal variable. And we get max 0. That's sad. Are you going to put this code in your Git repo? I don't know. I could. You think it's worth it? I don't know. Seems fairly basic. I think the most interesting part is the explanation more than the code itself. So why are we getting 0? Why is this thing not iterating at all? That's annoying. That is indeed annoying. Why are we not doing anything nice? It makes me think that line.len is never 0. So let's start debugging this a little bit. Should I use a debugger or should I use print debugging? Maybe iterator pick accepts pointer to self seems like that shouldn't need to be mutable. If that's the case, could be a bug, like a bug, a mistake in the source code that could be improved. Although, I guess it could be improved, but yeah, you kind of want to always put your iterators in mutable memory. I am tempted a little bit with the debugging, but okay, let's do print debugging. I guess that's what people who are getting started with Zig might be more used to, so let's do that. Okay, my question right now is, are we looping? I think we are, and I think we are simply never entering inside this case. Because this is where we do the bookkeeping, right? I think we are not entering in here, unfortunately. So std debug. What's happening? Debug.print loop, comma. Let's also print the length. So let's take a look at line.len. So we are iterating. Len is 4, 5, 4, 5. Okay, so we are looping. I don't see 0. I guess we don't see 0 because I'm using tokenize. And I think that tokenize doesn't never return empty slices. That's the problem. So what's happening is that we have a new line. So here's what the data basically contains. It contains some numbers, then a new line, then a new line, then a new line. I'm adding also, like, I'm going to another line just for visual clarity. There is no extra hidden new line in the source code. I think that's what it's seeing. So So the problem is that it would return an empty slice, but it never returns. But tokenize doesn't want to return empty slices. So I guess this is one of the relatively few cases where I think we want split. So split is pretty much like tokenize, except that it also gives you empty strings. Okay, let's see. Oh, now we do have a max. And we do have zeros. So, yep, now it works. 64929. Oh, there's also a problem that I'm having trouble copying from this terminal. Man, this is gonna be fun. Okay, 64929. Is this our answer? That's the right answer. One Godsar. Let's go. Let's see. It would make sense. Okay, so I guess one corner case could be that maybe you're passing the iterator as a read-only thing to a sub-function, which you expect to call. You want that function to be able to call peak, but you don't want it to modify the state of the iterator. So you give them an immutable one on purpose. But yeah, it's niche. I think that your point is, if peak is not designed, it should not modify the internal state, then yeah. Let me return to verify. Test case with simple input and known answer. This seems trivial enough. I think the exercise itself can act as our test case. It worked out, so yeah. Maybe the iterator caches the peak value. Nope. I should look at the source code for sure, but I don't think so. You have to understand that these the tokenized iterator is very thin, and you're iterating over an array of bytes. There is, you know what? Maybe you're right. I am a bit suspicious, but maybe you're right. So let's see, token iterator. Where's the token iterator? Do we have? I don't think we have access to the source. So this is a limitation of this is not a limitation of anything. Okay, token iterator, pick. Let's take a look. We are not. Is it in here? Token iterator. Oh, pick. There we go. So let's see. Const start, return null, while end. Nope. It does not cache anything. South is split byte. Yep. No, it doesn't seem to be caching anything. Unless, well, maybe is split byte is. Let's take a look. Nope. Does not seem to be modifying anything. Okay. So we solved our first exercise. Let's do the second one. Part 2. By the time you calculate the answer to the elf's question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. Huh? Okay. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, even if one of those elves runs out of snacks, they still have 2 backups. In the above example, in the example above, the top 3 elves are the 4th elf, blah 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 blah. The sum of the calories carried by these 3 elves is as follows. Find the top 3 elves carrying the most calories. Fine. Okay, here's my solution. And I am going to cheat. So I guess what you want to do now is like either keep 3 counters, or maybe, you know, split the computation into 2 steps, right? One where you collapse the numbers so that you have one item with the total calories per elf, and then maybe you sort the array. But why do this? When instead, here's what we can do. We keep this as is. We remove our debug print, or rather we repurpose our debug print as follows. So here's how it works. Every time we're swapping max calories with a new value, we print it. And as you can see, this has produced here the list, which then we can simply do this. I don't know, Python. Wait, are you serious? I don't have any Python in here, and Vim Python 3. Wait, what? Okay, Nix shell Python. Jesus. Can I have Python? No, don't need that. There we go. Okay, 64929 plus 64690 plus 62518. There we go. Can I copy, please? Oh my god. Okay, I need to do something with my system. I can't copy paste from the terminal. It's driving me insane. 192137. 37. Oh no, that's not the right answer. Wait. 192137. Did I mistype something? 64929. 690. 62518. Holy cow. I was hoping to cheat. You guess 19. Oh my god, it's 21 instead of 31. Ah, yeah. Okay, 19, 21, 37. $19, 20, 21, 37. Oh. Copy. That's not the right answer either. Wait. 1921-37. So no, this is exactly what I was supposed to get. So did I mess up something? Let me think about it for a moment. I mean, the maximum number is this one, that's for sure. That confirmed, that also matches the one that I put in earlier, right? 64,929. Yeah, so this is it. And the one before is this one. Wait, did I misread how you need to combine them? The sum of the calories carried by these three elves is... Find the top three elves carrying the most calories. How many calories are those elves carrying in total? Now I'm intrigued. There might be numbers in between second and third. There might be numbers in between second and third. Wait, aren't we supposed to find which are the elves with the most calories, right? Oh, I think I understand your point. Like, there might be somebody. We found that as the max. Oh no, my cheat is not working. So yeah, we found this guy as the max. Like, let's say the second one. But then we found somebody who has more than the third, but less than the second. We don't swap because it's not big enough. That is indeed unfortunate. Ouch. Okay. Okay, how I could probably try to cheat more. Why am I opening test one? I could probably continue with the cheating route. Because now that I have 3 candidates for the top 3, I could just try to print everything as long as it's bigger than this guy. But yeah. Yeah, okay. Okay, so I am tempted to continue cheating though. You know what? I think too many people are doing the right way. I want to do the wrong way more. So, right, the problem is there is most definitely something in between 62,000 something, 62,500 something, and the ones above. Maybe we can print everything above this number. That should maybe give us a cutoff that's big enough to not get confused. Like, do not get overwhelmed by the counts. So let's do this. If counter is greater than 64,000, let's do 62,000. Actually, you know what? Let's do 64,000. Let's see. That might be too high of a cutoff point. Oh, we lost our print statement. Okay. Well, what do you know? Here's our carpets. That was good enough. Okay, 64, 078 plus 64, 929 plus 64, 690. 1933.97. 1933.97. Let's see. Not the right answer either. Oh, the second number is wrong. Wait, what? Oh, you're right. It's 929, is it? Oh man, so close. Okay, 1936.97. How much do I have to wait now? How much do I have to wait? 1 minute before trying again. Oh god. Okay, 1936.97. Okay, I'm copying it. Let's submit. 19 seconds, okay. Kicking my ass, huh? That's my fault. I tried to cheat. There might be also numbers between first and second after you find first. I'm printing all numbers above 64,000. And it just so happens that we got only 3 of them. So there is no other number above that, above 64,000. So these are the top 3. Right answer. Let's go. Okay, let's return. Exercise number 2. Let's get ready for the exercise. Let's set everything up. Why do I keep opening test.txt? I don't know why. Oh, wait. Yeah. Oh, man. You're on Mac? I am on Mac, but I have a Linux virtual machine. I program inside the Linux virtual machine normally. The elves begin to set up on the beach to decide whose tent gets to be closest to the snack storage, a giant rock paper scissors tournament is already in progress. Rock paper scissors is a game between two players. Each game contains I hope it's not different than what people are expected to know already, so let's see. Appreciative of your help yesterday, One Health gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column, and suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response. X for rock, Y for paper, and Z for scissors. Why use different letters? Fine. Winning every time would be suspicious, so the responses must have been carefully chosen. Okay. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. That's a weird way of making stuff. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose that you were given the following strategy guide. In this strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, and you should choose paper. This ends in a win for you with a score of 8, 2 because you chose paper, 6 because you won. In the second round, your opponent will choose paper, and you should choose rock. This ends in a loss for you with a score of 1. The third round is a draw with both players choosing scissors, giving you a score of 6. In this example, if you were to follow the strategy guide, you will get a total score of 15. What would your total score be if everything goes exactly according to your strategy guide? Okay, this thing is assuming like a ton of rounds happening in a row. What the heck? Is this like did Nostradamus write this freaking guide? Okay, copy. Okay. Okay, so I guess we have to parse this bad boy and do the counting. So I guess same stuff. In this case, tokenize should be good. So var IT, std, mem, tokenize. Bytes, data, new lines, I think our lines are well behaved, right? We can just do column 0, column 2, easy. So I think it's opponent playing the first column. Also, I guess we want to homogenize this stuff, I guess. I don't think so I think for now we need, yeah, we kind of want to homogenize this stuff. So we want our own enum I don't want to make too many nice things. I still am in a mood of cheating and cutting corners, but I think it might not be a bad idea to do this. Const, I don't know. I don't know what to call it, like hand positions, hands. Let's call it hands. Rock, paper, scissors. Okay, so we want to switch on the opponent, which is line column 0, and if it's it's a character, so we are indexing inside a string, so we need to switch over characters. So if it's like an A, then we want to call it hey king, catch hands, yeah. So if it's an A, this is like oh, we can say that opponent is hands. Oh, you know what, which makes me think that this should be singular. Okay, hand, so this is like dot rock B C scissors. There we go. Const, I don't know, me. Switch on line 2. We have X, Y, and Z, right? Okay. So now we have this. We need to decide. So for now, we only care about our own score, right? What do we need to compute? What would be the total? What would your total score be if everything goes exactly according to your strategy guide? You could do a into enum. Yes, you could subtract your like ASCII starting point and do an into enum. Yes, for sure, you could do that. That works. Okay. Yeah, we need to do the calculation. Also, we need to do the calculation only for ourselves. The opponent is necessary for now, at least, only in the measure that we need to understand who wins between us. So, I guess the question is, do we win? Do we draw? Do we lose? So I don't know, match points? Okay, let's see. I guess match points depends on what we have and what they have. Jesus. Now I'm starting to itch for for a more tricky, like for a more compact way of expressing these. I guess it depends on the switch me, I guess. You know what? We could also maybe whatever. Let's do it again. Just switch me. Okay. We have rock. We have rock, and if the opponent has at that point we switch the opponent, I guess. If they have the rock, is a draw, which I believe it's like 3 points. Also, let's make this a U size. So rock, paper. Have a rock, they have paper, so it's 0 points. If they have scissors, it's a win, so it's 6 points. And I I guess it's the same thing 3 times. So 2. So rock becomes paper. Why did it duplicate? Okay, change. Paper. So we have paper, they have rock, we win. Okay, these comments are not useful anymore. Okay, paper, rock, we win. Paper, paper, we draw. Paper, scissors, we lose. Okay, I was hoping the undo would be more forgiving. So we have scissors. Actually, okay. If we have scissors, they have rock, we lose 0. If we have scissors, they have paper, we win 6. Both have scissors. We draw is 3. Now, I think it was 1 point if we had rocks, 2 points if we had paper, and 3 points if we had scissors on hand. This point I'm gonna call these points, and that's it. Okay, I think that with this we have correctly graded our an individual hand, so I guess we need an accumulator. Var total is 0. Total plus equals points. Right? I don't know. Hopefully I didn't mess up some of the math. So the one ends, and then SD, debug, print, total. Right? I don't know. That seems it. Let's take a look. Switch must handle all possibilities. Oh yeah, so, right. So here's the problem. We're switching on this character and it's not an A or B or a C, like it's something else. What do we do? Because it could be, it's a character. The answer is else unreachable, which means we don't expect it actually to really contain anything else, and if it does, we panic in safe release modes, like, well, safe, release safe, or debug. Otherwise, it's undefined behavior in release fast, but I think it's fine for our use case right now. Unreachable. If you wanted to avoid the undefined behavior, instead of doing unreachable, you do this, you do it panic. So let's take a moment to think about panic versus unreachable while we're here. Sometimes people use unreachable as a shorthand for panic. That is not exactly what the correct way of doing it. Unreachable is you communicating to the compiler that that condition is impossible, that that condition will not happen. Panic is instead that you are not sure that it will not panic. It's a unexpected condition where you want the program to crash, to panic in that case, but you do expect that to be potentially something that happens, and you do not want the program to misbehave in case that happens. You could also return error.invalid input. Sure, that's another example. Actually, I would argue that these are 3 distinct cases. Returning an error kinda tries to... The lines are a little bit fuzzy, so this is not something that is like clear-cut distinction between one case and the next. There are like gray areas, but generally speaking, if you are designing and returning an error, it means that you're probably like writing something like a library, and you want the caller to handle that error. If you're panicking, it means that you don't expect that there is a way of handling the error other than crashing the program. if you're a library author, you normally do not want to make the decision yourself. So you normally do not bake panics into a library. But if you're an application author, if you're like the top level programmer in a sense, like what I'm doing now, right? I'm not writing a library. I'm writing code that produces I'm inside the main function. I'm producing a final executable. I make the decision of what I think I can handle and what I decide to not handle, or rather I decide to handle through crashing. So that's a thing. But unreachable is different. Unreachable is for impossible cases. Now, in this case here, it depends on how you want to see this. But I argue that in this case, unreachable is the correct choice, because in Advent of Code, we can trust the input. We know that the input doesn't have random errors in it. We know that the input is always well-formed, well-correct, so we don't need to account for errors. Now, there could be an error in my code, so the input might be well-formed, but I mess something up in here. I don't know, I mistyped Z, I put S in here, and now actually what I think is impossible is possible. That would be a pretty big mistake, yes. But that's why unreachable in debug mode and release safe behaves like panic. That's why unreachable, instead of enabling optimizations, produces a safety check. So in any case, I see no reason for main to return exclamation point void unless you expect to maybe return an error. Yeah, I put an exclamation point in there because I had to put try before, because one of these guys was returning an error. I don't remember. It was parseint, right? Because parseint was returning an error. That's why I preemptively put an exclamation mark in there. Here's the thing. I took a moment now to think about this design decision, like this language feature, but really, again, it's Advent of Code. Doesn't matter much. Still, I want to point this stuff out since we're here to learn a little bit of Zig. Okay, let's take a look. Value with comp_time only type. Comp_time int depends on runtime control flow. Oh. Are you really annoying me? Are you really annoying me about this? So what I think I'm getting is an annoying type error where it thinks that it's producing like a comp_time int expression, while in reality I want this stuff to be usize. So let me do this. I think this will fix it. Also interesting that AI complains here. Okay. Okay, I don't know, maybe this fixes it, maybe I need to put it somewhere else. No, I need to put it somewhere else. Okay, I think it needs to go in here then. I'm basically forcing that 3 to be a runtime type of int. There we go, okay. Oh, and with the undo I also need this. Yeah, there we go, and we need to do this for every branch. Yeah, that's an annoying thing that I need to hopefully be made nicer in Zig in the future. There we go, this is the total. What I'm saying is that if you propagate errors, then you can also return your own. Yeah, for sure. There is, though, an intent behind things. Like, for example, in this case, propagating my own error or causing a panic is pretty much the same thing. Okay, 13565. Well, I mean, that thing can be improved in Zig, maybe. This has been on for a long time. You don't need Advent of Code to show you that. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose. Y means you need to end the round in a draw. And Z means that you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above goes something like this. Blah, 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 blah. Now that you're correctly decrypting the ultra top secret strategy guide, you get a total score of 12 in that thing, okay. Following the elf's instructions, what would your total score be if everything goes exactly according to your strategy guide? Okay, so now we need to reinterpret this thing in a different way. So, we were thinking that this thing was telling us what to play. Instead, it tells us what the outcome should be. So, in a sense, we need to like do a transform and move the comment into a switch case. Okay. So, opponent, I guess me now becomes outcome. So we switch on the outcome. But the outcome is not a hand anymore. Let's make a... You know what? We don't really need to, at this point, to make a nice... We don't really need to make a nice thing for it anymore, I think. So we switch on the outcome. And the outcome is X, which was a loss or win? X means loss. Okay, so this is loss. So if it's lost, then it means it's 0 plus whatever we get here, which is rock is 1, paper is 2, scissors is 3. Wait a second, no, that's not how it works. Because if the opponent has played rock, then the opponent has played rock, we are aiming to lose, then it means that we need to play scissors, which gives us 3 points. The numbers are like inverted now. The opponent has played paper, that means that we are losing, that means that we need to play rock, which is 1. The opponent has played scissors, then it means that we need to play paper, which is 2. Then Y, I think Y is draw, correct? Yes. Okay, so opponent has played rock, we need to play rock. Now this is the normal mapping. Paper 2, scissors 3. Now this is the win case. Also, draw is 3 points. Win is 6 points. So the opponent has played rock. We need to play paper, which is 2. Opponent has played paper. We need to play scissors, which is 3. Opponent has played scissors. We need to play rock, which is 1. I guess this is it. Oh, and so 2 problems. Yeah, so outcome is nothing anymore. This is how line 2. And we need an else case. Also, fun fact, the else branch can also be put up top. It doesn't have to be at the end. Well, 42-4. I don't know. Let's see. Chances are that I got something wrong, but 12, 42-4. That's the right answer. There we go. Day 2 is complete. Okay, let me see how I'm doing on time. I think I have time to also attempt day 3. That could be nice, right? We do first 3 days, and maybe tomorrow we catch up. Maybe that's a bit too optimistic, but tomorrow or the day after we catch up, I think. So let's go, day 3. Let's get ready for day 3 also. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Oh god, is this the old Dropbox hiring quiz? For those who remember. Each rucksack has 2 large compartments. All items of a given type are meant to go exactly into one of the two compartments. Oh, like in Pokemon, okay. The elf that did the packing failed to follow this rule for exactly one item type per rucksack. Okay. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, A and A refer to different types of items. Nice. The list of items for each rucksack is given as characters, all on a single line. Why did you scroll? Why did you scroll? A given rucksack always has the same number of items in each of its two compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. The first rucksack contains the items blah blah blah, which means that the first compartment is this, second compartment is that. The only item type that appears in both compartments is lowercase p. Okay, I guess this sounds like set intersection. The second rucksack, blah blah blah. The only item type that appears in both compartments is uppercase L. The third rucksack compartment contains blah blah blah, P, fourth rucksack, blah blah blah, blah 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 blah. To help prioritize item arrangement, every item type can be converted to a priority. Lowercase item types A through Z have priorities 1 through 26. Uppercase item types A through Z have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16 P, 38 L, 42 blah blah blah. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Okay. Copy. Data, paste. Okay, const std equals me, import. Embed file, data, the txt, no, pub function main, void. Okay, I guess we want to build sets of these things, intersect, find the intersecting thing, assert that it's only one the intersection, just, you know, to make sure, because that's, I think, what the prompt said. And then convert that to a number and add as usual. What's your ethnicity? I'm from Italy. Half, I guess. Other half is Central America. My mother is from Central America. Never been there though, so. Okay, let's do it. So, usual iterator. As usual, we want to iterate on lines, so U8, data, new lines, and then we do for each line. Okay, what are we gonna do for each line? We need to kind of split it in half, right? So we need to find the length and divide it by 2. We expect it to always be even, because they say that they put the same amount of items on each side. So yep. So yeah, let's do it. Yes, middle. Yeah. Divided by 2. I think we have a nice built-in for this in Zing. Let me double check. I think we have like div int or something like this. Int div. Int cast. Okay, let's see. Okay, you know what? It's easier probably to do this. Div exact, div floor, div exact. That's what we want. Yeah. Div exact, exact division. Color guarantees denominator different than 0. And yeah, we can do div exact. I think that's nice. Yeah. Not that important because, but you know what? It could be nice in case our assumptions are wrong. Oh, and it doesn't want any types. It just wants the 2 arguments. Fine. There we go. No, so, I mean, I don't think I'm getting this wrong, right? Seems very simple. The fact that since there is an equal number of items on each side of the rucksack, the length is always going to be even. But it's nice, I think, when you're doing advent of code to use these precise operators that panic on you instead of producing unexpected results. And I think if I use like normal division, things would have been fine anyway. I think maybe not actually. Actually, no. I think that normal division produces a float, right? So this is nice. This should help us stay in the integer realm. No, dude. What? Why are you doing? Why are you like this? Okay. So we have the middle point. Now that we have the middle point, we have left and right, right? Const left is line 0 dot dot middle. Const right is line middle dot dot line dot len. There we go. We have both sides. Now we need to intersect them. There might be, I don't know, maybe smarter ways of doing this, but I'm gonna go with this approach. So function make set takes a slice of bytes and returns a std dot auto. Oh, you know what? Let's make a nice type for this. Item set. Auto hash map. Okay, our keys are not going to be strings. Our keys in this case are going to be bytes because each item is a byte. And the value is going to be void. It's just a set. So we ask for a make set asks for this and produces a item set. Now item set hash maps need dynamic allocation, so we also want to ask for an allocator. Actually, this is going to be our first argument. Oh, we don't need the pointer anymore. There we go. So var I don't know, set equals item set. Does it have init? It does have init. And it wants an allocator. There you go, buddy. You get your allocator. And then for each character inside, oh, we need to give a name also to this argument. Items, I guess. Man, why is ZLS doing this? Okay, new ZLS has features that I don't want because they don't work well with Helix. So for items, item, I guess, even though it's just a character, but whatever. We get an item and we do set dot add. insert, put, there we go, put what? The item. Now, the value is void, but the signature still wants us to provide a value. So if it's void, what do we provide? The answer is curly braces. Curly braces is an expression in Zig, like it's a block that evaluates to the void value. There's a difference between the void type and the void value. The void in auto-hashmap is optimized out by the compiler? Yes, correct. But you still have to, like, signatures don't get automatically, don't get syntax sugared. So you need to provide the second argument. In practice, since this is a 0-bit value, it doesn't matter. Usually a void type isn't usually void a type that has no constructor. Yes and no. So I don't know what other languages do. I think the void technically seems to imply that it's a type that doesn't have any element, but that's not what it is. In practice, void is a type that only has one possible value, the void value, which usually doesn't have much of a name. The type that cannot be constructed, that doesn't have any, I don't know, case in it, in Zig is called no return. That's the empty enum. Think of it as an empty enum. Like it's an enum that doesn't have any case. While void is like an enum that only has one case, which doesn't really have a name for us. It's like, I don't know, Voldemort. Like, Voldemort. So void is an enum with only one case. No return is an empty enum. Anyway, this is like, doesn't matter much. Know that you have to put the curly braces if you're making a set out of a hash map. Okay, we put everything in there and then we just return it. Plain and simple. Is it a problem to copy a set? Go to definition. Can we copy this bad boy? Drop of a hash table, no order is guaranteed. It provides for a hash map that can be initiated. If iterating over, context, adapt the variance, take up pseudo key instead of a key. I think that it's not mentioning anything, so it shouldn't be a problem to copy it. Okay, so you know what? We can just straight up do this. Okay, we need an allocator, so var GPA equals std.heap. General purpose allocator takes a bunch of comp time options that we want the defaults of. Then we create an instance of it, and then we do allocator is GP. You know what? We can just call it on the fly. So make set. Okay, left and right now are sets. Now what do? We intersect. Do we have intersect? I worked off of the assumption that we have the ability to intersect, but we might not have that. Let me double check with the documentation here. Capacity, clear and free, clear, clone with allocator, contains adapted, ensure capacity, fetch, put, assume capacity, fetch, remove. I mean, it is a hash map more than a set, so it might be that it doesn't have that function. Ooh. Well, I was hoping, but it turns out that our thing doesn't implement that. So we need an alternative approach. We can't just call make intersection. So here's what we do. We make a set of left. We do not make a set of right. Instead, we iterate over right. Yes. And we do. Here's what we can do. Look at what we can do, which is interesting. So we iterate over each item, and then we say if, i.e., remove the curly braces on purpose. If, well, okay, let me do it in order, I guess. So our result is const. This is, we expect only one item, right, to be shared. So let's call it shared. The share item is calling this for. Then we do if left dot contains item. Contains is the thing, right? Contains. Yes. If left contains item, then we continue. Else, we break with item. And I think I need an else. Oh, and I don't need this. There we go. I think I might need an else branch for the for loop. That's the only thing that I'm missing. So here's how it works. By not putting curly braces, I'm chaining all these expressions. So the body of this for loop is this if expression. This if also on its own is an expression if. It's not a statement because it doesn't have curly braces. So if we contain the item, we continue the for loop. Otherwise, we break with the item, which assigns the item to shared. The only problem, the only thing that's missing is that the for loop, in theory, could keep hitting continue and continue until the end of the iteration, at which point it has not returned anything to us. So I think we need to do another else, and we need to say, okay, what if we didn't find it? What do we do then? To make the type system happy, it should be something like this, right? Let me save. Yeah, you can see that this else shows kinda, it's like an else branch for this for. It's what happens if you reach the end of iteration without breaking from it. But we don't have a good value to put in shared. And also, in our case, we don't expect that to be the case, right? We expect to always find one item. And actually, we are also, the fact that as soon as we find one, we break and we stop checking, we're also leveraging the assumption that hopefully didn't get wrong, that there's only one item that's shared that we need to take care of, not more than one. So here's what we can do. This is a condition that we don't expect to reach. So else, unreachable. That works. Unreachable works with all coerces, kinda. Like, it satisfies the type system always, because you're not supposed to reach it. That's really nice, because that's exactly what we expect to be the case, right? We don't expect, given that we are in advent of code, given that we can trust the input, given that we do not need, from a programming perspective, to handle malformed input, we can make the statement that we don't expect the for loop to ever fail to find the one overlapping item. So we don't have to worry about this. Unreachable. There it is. So we found our shared thing. Now we need to do the count, right? So we need to transform the shared thing to the prioritization stuff. So here's a question now. Can I just subtract uppercase A and call it a day, or do I need to treat uppercase and lowercase separately? I don't remember. Is uppercase A right after? I think this is 65, right? 65 plus 26. That's 91. I think uppercase A is 97. So I believe there is something between lowercase z and uppercase A, right? So I need to treat them separately. Okay, so so now we want the what was it called? Priority. Const priority is switch shared. Okay, the case from A to Z, we do one thing. There are characters between Z and A, thank you, yeah. I assumed as much. Comma, and then there's uppercase A to Z. The reason why these are 3 dots instead of 2 is because this is a range that also includes both extremes. It's a closed range. So that's different from, for example, when you're doing slicing. When you're doing slicing, here I'm slicing, the upper number is not included. So that's why these are 3. Okay, so if it's between A and Z, we, I guess, just do shared minus A, and that's it. Otherwise, we do shared minus A. Uppercase A. And that's our priority. Is that it? That wasn't any more than this, right? Yeah. And then you have to sum those. So total plus equals priority. And then we print. Okay, total. That should be it, right? Let's see. Okay, what's wrong? Switch must handle all possibilities. Oh, yeah. We don't expect that to be a possibility. What else is there? Error is ignored. Right, putting items inside a thing could fail. Because it could require to allocate memory, which could fail, so that's why this thing can fail. So we return an item set or an error. I'm just saying this because for learning purposes, this really does not matter for the purposes of Advent of Code. But if we return with an error and we have allocated some memory, maybe we successfully put in, I don't know, a billion items and then we ran out of memory afterwards. If we just return the error like this, then we have a bunch of like dirty memory. So we also need to do this. So here's what's happening. If everything goes well and we return normally, like we never error out and we just want to return the set, then that's fine. But if we are returning with an error caused by this line, then before returning, since we are returning with an error, we are not returning with the item set, we want to free the item set. So that's what error does. Again, not that important for the purposes of Advent of Code, but if you're learning Zig, that's something to keep in mind. Okay, let's see how this goes. Error. No field member function contains in typeinfo main. Oh yeah, okay, so this beautiful error message that definitely needs to be improved is telling us that now we are not returning an item set anymore. Now we're returning an error union. So we need to try make set. Or rather, we need to unwrap that error one way or another. Okay, let's see. There's still a logical bug. Okay, then we'll figure it out soon. Oh, I guess I know what it is. Shared, like if it's A minus a, that's 0, while a is supposed to be 1, I guess, right? Yeah, so we need to do plus 1. Do we make this view size? Okay, this has 4221. There's a second bug. Okay. The priority of the item type that appears in both compartments of each rucksack is blah blah blah. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Okay, what's the bug, Akuras? I'll try 4221 in the meantime. Not the right answer. Check uppercase priority case. Oh. $27. Oh shit. Yeah, it's 27 plus. Oh man. Yeah, you're right. I need to subtract A, but then I need to do plus. $27, I guess? No, plus 26. You know what? I'll do plus 27 here and plus 1 here. And remove the plus 1, yeah. Okay, 78.87. Thank you. Yep. I guess now I'll need to wait. I'll have to wait 60 seconds to try again. 9 seconds left. Come on. 4 seconds left. Intersection is wrong. You think so? Am I doing the opposite? I don't think so. Oh shit, no, you're right. I'm doing the inverse, am I? If the left contains, I should stop. Otherwise, I should break. Otherwise, I should continue. Maybe should have put a knot in there. Wow. If the item, yeah, is shared, then we break the search. We're good. Otherwise, we continue. Yeah. 78.26. Okay. Thank you. Yay. Okay, as you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Okay. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. Okay. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in the rucksack. And at most, 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on their badges. All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines. That is making me wish for intersection a lot more than before. Although it shouldn't be that bad still. Okay, so this is the first group. This is the second group. In the first group, the only item that appears in all three rucksacks is the lowercase l, so that must be their badges. In the second group must be blah blah, blah z. Priorities for these items must still be found to organize the sticker attachment efforts. Here there are 18 and blah blah blah. The sum of these is 70. What is the sum of the priorities of those item types? Okay, so first, originally we were merging this stuff like horizontally. Now we need to do 3 lines at a time. So let's hope that the total number of items can be divided by 3. Again, we usually can trust this thing to 300. Looks like so. Okay, so here's how it works. Yeah, we are tokenizing line by line, but now in reality, here's what's happening. Let's call this line 1, and then we're doing also this const line 2 is it.next. Line 3 is it.next. So even though we are using the while loop to drive the looping with the iterator, nothing bad happens if we basically pull from the iterator twice, like a little bit inside the loop. Everything needs, like the modulo math needs to work out correctly, right? So we can only do this without problems. Also, we need to do dot question mark. Yes. So we need to unwrap the null because this could be returning null. That's why. But and this is the panicky. This is the unreachable equivalent of asserting that something is not going to be null. This is panic in release safe modes. This is undefined behavior, like undefined in release safe. But again, 300 lines, so we know this is going to work always correctly. Okay, so now we have line 1, line 2, line 3. We have the entire group. Now we need to basically do what we were doing before. Instead of doing it horizontally, we do it vertically. So I guess we don't care about the middle anymore. Maybe we could care about the middle if we wanted to maybe prune items that are on both sides, but I don't think it matters in our case. I think with 300 items we shouldn't worry about this, so we don't really care about left, but we need let's say I don't know, elf1. For elf1 we make a set from line 1 and then here's the problem. Stopping at the first shared item is not enough. Because once we find a shared item, now we need to test if it's in the third item. Here's the annoying part though. If we do this in a naive way, we redo a lot of computation over and over, because like we find a shared item between 2 of them, and then we start checking the third one from the start every single time. And it would be nice if we could like somehow save state with the third thing. But I think that if we do this in Zig with 300 lines, taken it by groups of 3, I think we can brute force our way through this. Let's test this assumption. So we would want, like, ideally a more optimized algorithm, and if we had an intersection operation in hash maps, this could be easy. But it seems that we don't. So you know what? Actually, let me double check. Maybe there's another type that has something like this. But intersection. So we have intersection in bit set. Enums index set. Then okay, so bit set, integer bit set, array bit set, and dynamic bit set. These guys have set intersection. That's unfortunate though, because these are like for bit, for messing around with bits. That's really unfortunate. That's not what we need in our case. I guess we would be nice to have either set operations on hash maps or a proper set type, I guess, for this type of stuff. But we don't have it for now, so we'll make do with what we have. I could also implement it myself. Like, I could turn all 3 of them into hash maps, and then for each key in the first one, check if the other 2s have it. That would work. You know what? That's how I'm gonna do it. No need to have weird brute force stuff. So elf1 const elf2. You know what? elf2, elf3. Line 2, line 3. Okay. And then we want to iterate over the keys in elf1. It doesn't matter which one we pick, right? Because we're looking for something that all the 3 of them share. So const shared is going to be for something something elf1. There's a key iterator. Yeah, but if we want a key iterator, we cannot use it with for, right? So here's what we're gonna do. I don't remember if it's auto array hashmap or array auto hashmap. Auto array hashmap. Okay. This is a slightly different implementation of hash maps. This one is good when you need to loop over it. It has better performance than the other hash map implementation, and it also has a nicer way of iterating over the keys, because you can do .keys, which returns you a slice of keys. Like this is a hash map implemented on an array. So I changed the item set to array hash map. This stuff shouldn't change at all. But then in here, we can now actually use for real. We don't need an iterator. We can just loop over elf1.keys. That gives us a key. And then here's what we do. If elf2 contains key and elf3 contains the key, if both of them contain the key, then we found it. We break with the key. Else, continue. Else, if we never break out of the thing, not yield k or something like this, break k. Break is what does what yield does in other languages. But then if we iterate over everything and don't find anything, we don't expect that to be a possibility, so it's unreachable. There we go. So that gives us shared. Shouldn't be too bad. So linears, well, it's a bit of construction, but then a linear scan. Then we sum everything together, and I don't know what we get. What do we get? 2577. That's the right answer. And we completed day 3. So I think that's it for me today. I'm gonna call it a day. Wasn't that bad. Few stumbles, not perfect, but hey. Review for Zig. So how did Zig? Okay, so Alcras, I'll do your point about using Advent of Code to evaluate Zig and things that are missing. Again, this is not really the main domain for Zig, so I wouldn't exaggerate in trying to optimize Zig for being comfortable for Advent of Code, but it would be nice if the standard library had a proper set data type, because intersection is nice. Although, I mean, we found out that in the end, we didn't really need it. It wasn't that bad. If we were to use intersection, we would have to produce 3 sets like we are now, and the intersections between these things pretty much works like this. There are optimizations that could be done compared to maybe what we're doing now. Oh, rather, sorry, this is not a general purpose intersection, right? This is, we stop as soon as we find one item in the intersection, because we know there's only going to be one. So that's a specialized case. That's actually better than general purpose intersection from that perspective. So in the end, it was fine. I don't think I have anything else to say. It's working out. Not sure if you already mentioned, but bitsets have set intersection methods. But wait, could I use... Wait, isn't bitset expected to be used with, like, bits? Could I have used bitset in this case? Would it have worked as... like, for this use case where we have, like, bytes as items? U8 is small enough. Okay. Well, so maybe there was another possibility. Still, this is not that bad. Another nice thing is the use of unreachable. You saw the nice syntax for loops. This is like the, I think of it as the searching. It's like the detective syntax for loops, right? You're using a for loop to find something. So either you break because you found it, or you keep iterating until you exhaust your array, and at which point you have the else branch for this for loop where you handle the case where you didn't find what you were looking for. In our case, given that it's advent of code, there is no error in the input and what we are told in the prompt, we know that we're always going to find what we are searching for. And so we can say, you know what? It's never going to happen that we don't find what we are searching for. In any case, when I do zig run, this is going to run in a debug build, and so if my use of unreachable is incorrect, I will get a panic. I will not get undefined behavior. Let's see. So you would just have to subtract the bytes to get 0 n. That's fair. You could just choose to use a static bitset 256 maybe. Understood. Interesting. Yeah, I didn't consider that. So I guess that was another possibility. Still, I think we kind of could make do pretty well with a simple hash map. And with this, yeah, I'm calling it a day. Thank you, everyone. I will continue for a while more. As long as the exercises are this simple, shouldn't be a big of a deal, but we know they're gonna get more tedious. And the reality is that I actually don't mind a bit of a more challenging exercise. It's fine. The problem is that I have other things to do, and advent of code is nice as long as it's useful for everybody else. Otherwise, I don't feel like it's productive use of my time. That's why I will probably stop once once I stumble a little bit too much and it becomes a little bit too tedious. But hasn't happened yet, so we'll see how far we'll get. Have a nice Monday, and I'll see you next time. Have a good day. Bye.